Much, Susan, and on to our next speakers. We have a group of speakers, and I'm not sure which of the group is going to present. They are colleagues from the University of Ghent, and they will talk about using eye tracking to assess the readability of machine-translated literature. And may I ask the presenter of the group to share his or her screen?
Yeah, it's actually only me that will be presenting. So can you hear me now?
Yes, we can. Yeah. So welcome, John Colman.
So hello, everyone. My name is Toon Colman, and I work as a research assistant at the Language and Translation Technology team of Ghent University. And today I will present to you our ongoing eye tracking study on the readability of machine-translated literature. This is really an ongoing project, so I will mainly try to explain the rationale behind the project to you and show you some preliminary results. So this present study actually takes place within a larger overarching project called AristoCAT. AristoCAT stands for Assessing the Comprehensibility of Automatic Translations. And the overall goal, the overall objective of this project is to evaluate the comprehensibility of a raw machine translation output, so that is unedited machine translation output, for readers who can only rely on this empty output. In the present eye tracking study, we want to compare the natural reading process of participants reading a full novel in a human translation versus in a machine translation. We are interested in how the natural reading process is affected by MT, and to what extent that various types of MT errors impact the reading process. So, as discussed earlier, and as you might already know, the quality of machine translation has improved significantly over the last few years, mainly thanks to this paradigm shift from older statistical MT systems to a newer generation of neural systems. Despite these overall big improvements, however, literary machine translation remains very challenging. And therefore, literary text is, in fact, a perfect research case for us, because we want to study the effects of MT on natural reading behavior and the effects of MT errors. So literary MT is a case where there are quite a number of errors, which makes an interesting research case for us. The difficulty of literary MT is perfectly demonstrated by a previous study from the AristoCAT project by Fonteyne and colleagues. In this study, they generated a Dutch Google Translate version of an original English novel by Agatha Christie called The Mysterious Affair at Styles. After generating this Google Translate version, they analyzed the quality of the output using the SCATE MT error taxonomy. Using this taxonomy, they found that as much as 56% of the sentences contained at least one error, so that's quite a lot. And the most frequent error type was mistranslation, followed by coherence errors, followed by style and register errors. In a follow-up study, they actually analyzed 4 more classic novels and found very similar results, and also a similar top 3 error types. So here you can see this error taxonomy visualized along with the most frequent types of MT errors. So for example, mistranslation. A mistranslation from the novel was come and be refreshed, was translated as come and wordt vernieuwd. So this means something like come and be renewed. Refreshed was mistranslated into renewed. The result of this study is that we now have a full Dutch Google Translate version of this novel, annotated on MT errors. So we have info on where in the text there are MT errors and what type of errors they are. And this is exactly the material that we are using for our present eye tracking study. Now, what was the reason in the first place to choose this particular novel by Agatha Christie? Well, most importantly, the professional published human translation of this novel was previously used to create an eye movement corpus of monolingual and bilingual reading. This corpus was called GECO, short for the Ghent eye tracking corpus. And in the present project, we are expanding GECO with eye movement data of the MT version. So our new corpus can then simply be called GECO MT. So in the original GECO corpus, they collected eye tracking data on the original English version, displayed on the left, and the Dutch translation. So for example, total reading times per word. And in the present project, we are again collecting data on the Dutch human translation, but also on the Dutch machine translation. So let me quickly recap our research goals. In the first place, we want to provide this big corpus of natural eye movements during the reading of machine translated literature. This corpus will be available online for researchers to use for their personal research goals. Second, we of course want to use this GECO MT corpus to also answer some of our own research questions that we have. We are interested in how the natural reading behavior is affected by MT in general, and to what extent that various types of errors, according to the SCATE taxonomy, for example, impact eye movement. In order to collect all this data, we are running quite an extensive experiment that is heavily based on the original GECO experiments. So I will quickly go over the experiment. We are testing 20 participants, and each of our participants comes to the lab 4 times, so for 4 experimental sessions. In each of these sessions, the participant reads 1/4 of the novel by Agatha Christie, alternating between the human translation and the machine translation. So half of our participants start with the human translation in session 1, continue with the machine translation in session 2, and so on. The other half of our participants starts with the machine translation. While they are reading this novel, we collect their eye movement data during the reading. At the end of each chapter, we also have some comprehension questions, mainly just as an incentive to keep reading and motivate them to try and follow the plot of the novel. Importantly, at the end of each session, we also have some language proficiency tests. So, for example, lexical decision tasks, which are a type of vocabulary test in English and Dutch, and also spelling tests in English and Dutch. It is interesting to have this information on the language skills of our participant so that we can account for any potential effects on the reading behavior. So this is a picture of a participant during our experiment. So the novel is presented in paragraphs on the screen. This here is the eye tracker collecting the eye movement of the participant during reading. And this thing under the head of the participant is simply a chin rest, which is used to make sure that the participant doesn't move too much, because this is not good for the quality of the eye tracking data. So the most important piece of our data is, of course, the eye movement data. Eye movement data actually consists of 2 basic components. First, we have eye fixations. These are the instances where our eye remains relatively still and we actually absorb information from a certain piece of text. So that's indicated in blue on the text here. And second, we have eye saccades, and these are the jumps or the quick eye movements between individual fixations. Based on these 2 components, we collect a very large amount of eye tracking measures that inform us on the cognitive processes underlying reading. So, for example, we collect the number of eye fixations, the duration of these fixations, also the saccade amplitude, which is the size of these saccades, the movements between the eye. Also the number of regressive saccades. So there are saccades, these are saccades going backwards in the text. So sometimes a saccade goes to the left instead of to the right when a participant is rereading something. So we have we have data on all these measures. And in a nutshell, as eye tracking pioneer Keith Rayner states, when text is more difficult to read, fixations tend to get longer, saccades get shorter, and more regressions are made. This has actually previously been observed in the reading of machine translated text. So for example, in an earlier study by Doherty and colleagues, they noticed that there is an increased eye fixation count and an increased gaze time when MT output is rated as bad as human evaluators compared to better MT output. And in another study by Stimne and colleagues, they also found this increased eye fixation count and gaze time on errors compared to correct MT output. So this suggests that eye tracking can indeed be used to assess the readability of machine translation output and aid in assessing the seriousness of different types of errors. So I will now show you some results on our corpus. This is in progress. So we have now tested 10 participants, and everything that I will show you is based on these first 10 participants. So first of all, our corpus actually exists at two different levels of analysis. First, we have the paragraph level, and here we collect measures that compare human translated paragraphs versus machine translated paragraphs. So measures that we have at this level, for example, is the reading duration for a paragraph, the total number of fixations on the screen, the median saccade amplitude, the size of these saccades, sorry, and so forth. The second level is the word level. So here we collect eye tracking measures on individual words or short sequences of words. This is also the MT error level, since our error annotations can be linked to these individual words. So measures that we collect are, for example, the gaze duration on a word, which is the sum of all first pass fixations, whether a word is skipped or not, whether a regression is made to a word. So here you can see an example of such a regression. And we can compare then these measures between the human translation and the machine translation. So first and foremost, we seem to replicate these previous findings by Doherty and Stimne. So we also find an increased number of eye fixations when reading MT. And we also find this increased gaze duration when reading MT versus the human translation. Related to this is the very simple finding that reading a machine translated paragraph takes just that slightly bit longer than reading a human translation paragraph. So here you can see the number of fixations visualized. So obviously the number of fixations increases with the length of the paragraph that is visualized on the x-axis here. But systematically we can see that reading an empty paragraph of the same length as a HT paragraph counts more fixations. Same story for the gaze duration. So gaze duration increases with the length of a word, but the gaze duration for an MT word is systematically a bit higher than the gaze duration for a human translated word. Some more unexpected findings were that we didn't find a decreased amount of skipping when reading machine translation. So the amount of words that were skipped. We actually found a slightly increased amount of skipped words when reading MT. And there was also no clear difference in the size of these saccades, these jumps between the fixations. It is possible that reading machine translation becomes rather demotivating at a certain point, and that this increases the word skipping during reading, and increases also the median amplitude of the saccades. So here you can see the skipping visualized. So short words, very short words, are almost always skipped. Very long words are almost never skipped. And the medium words is where the variation happens. And here we found in our data that the empty words are skipped slightly more often than the human translated words. And here we have the saccade amplitude, so we don't see a clear difference here. The median saccade amplitude is quite similar between the machine translation and the human translation. Interestingly, though, we do find this increased amount of regressions when reading MT. So the proportion of words receiving at least one regressive saccade is higher in the MT version than in the human translation. Participants reread unclear pieces of text more often when reading MT. So here you can see this difference visualized. Okay, so this project is really in full swing at the moment. We are still collecting data, analyzing data. So I hope I gave a more or less clear overview of what the rationale is behind this project. And I will now wrap up by taking a look at some of the next steps within this project. So first of all, we want to analyze the full GECO-MT dataset when it is complete, using the linear mixed effects model as a statistical framework. So using these models, we can test whether the effects that we see in our data are actually statistically significant or not. So this is an example of a linear mixed effects model to test the effect of translation on gaze time. But I will spare you the technical details for now. Second, we of course want to zoom in on the machine translation error level. So now we have looked at general effects, the general effects of MT versus human translation, but we want to zoom in on what types of errors that really provoke these increased gaze durations, this increased regressions, and so forth. So for example, what is the effect of a mistranslation versus a style and register error, which has more effects on reading behavior. Lastly, we also have our language proficiency data, and we want to link this data to our eye movement data. So for example, something that we might expect is that participants with higher English skills might have less negative effects on their reading behavior when reading MT, because they might have more insight into what was lost in the translation, even though they don't have access to the original source text. So I hope that was more or less clear to you. If there are any questions, I am happy to answer those. Thank you for your attention.
Thank you very much, Toon, and thank you also to your co-authors, whom I forgot to mention when I first introduced you, Margot Fonteyne, Daems, and Lieve Macken, all colleagues of yours from the University of Ghent. We have one question in the chat so far, so feel free to put in more questions into the chat. And the question is about the layout in your study. The question is having the text-centered part of the design, or is having the text-centered part of the design. In the picture with the participant, the text was centered, but in the components of eye movement slide, it's not. I assume that there could be differences between the two layouts in terms of the data.
Yeah. So in this picture, because yeah, I can't actually take a picture of the participant during the actual data collection. So this is just a picture of the instruction screen. And what we have here is a screenshot of the actual reading, the actual paragraphs that are read during the experiment. So this is how the text is presented. So it's actually not centered as on the picture here. Maybe I should add a picture with where the computer screen shows this.
Thank you very much.
That would indeed have effects.
Mm-hmm. We have another question from Antonio. I was wondering whether pupil size measurements could be useful in any way in your study.
Yeah, that's a nice question, because pupil size is indeed an important marker of cognitive load. So we would indeed expect increased pupil size when reading machine translation that is not very qualitative. But the problem with these pupil size measurements is that they are quite sensitive to other effects than the cognitive effort. So for example, if a participant is tested in the morning versus in the evening, even whether they have drank a lot of coffee or not, they all influence these measurements, and the eye movement data is much less sensitive to this. But we collect the pupil size measurements, so we can certainly look into this data also.
Okay, thank you. We have one more question. Let me see. About how we can be sure that the translations are not yet in the training data.
Yeah, I am actually not sure whether they are already in the training data, but the main point of this study is that we want to see how MT errors influence natural reading behavior. And we needed a case where there are enough MT errors. In our MT translation here, we have 56% of sentences that contain an error. So that's good for us. Then we can see effects of MT errors on reading behavior. But I don't know whether the novel might have been included in the training data of Google Translate. Yeah.
Okay, thank you very much. We have time for a few more questions. If you have a question for Toon. If not, I would like to ask you one question. Is there a way to take into account personal reading styles?
By participants or?
Yes, by participants, because it seems to me that some people just naturally tend to skip words or parts of sentences.
Yeah. Good question. So this is something that we clearly notice indeed in the lab. Some participants their time to really read everything very detailed and reread often. Other participants just skip a lot and go over the novel very fast. But importantly on this question, I'm looking for the design. Yeah, so we have data on the human translation and the machine translation per participant. So each of our participants reads both the human translation and the machine translation. If we would let half of our participants read the human translation and the other half read the machine translation only, then this would be a big problem, because then it's possible that the participants in the machine translation condition have a different reading style than participants in the human translation condition. But since we let each participant read half in MT, half in HT, these reading style differences disappear when averaging all our data. So I hope that's clear to you.
Yes, thank you. Thank you. One more question from Antonio. How long were the sessions? If they read 1/4 of the novel in each session, it seems they had to be quite long.
Yeah, it's quite an intensive experiment, but luckily it's not a very long or a very difficult book neither. Each session takes around 2.5 hours. So the full experiment takes 10 hours for one participant. And the reading itself takes 1.5 hours per session, but they have enough breaks. So every 15 minutes approximately, our participants can take a break.
Okay, thank you. Because I was asking whether there's a difference between the beginning of the reading process and the very end. But if you take many breaks, I guess that's not.
Yeah, but that's true. It's also correct remark. Sometimes participants, their reading style can differ throughout the session. So at the end of the session, they might start reading faster because they want to get it over with. That's certainly possible.
Yes, thank you very much. We would have a minute or two for another question, if you have one for Toon. Okay, then can I ask one more question? You said your next step would be to correlate it with errors. So what do you expect regarding the types of errors and the influence they might have?
Yeah. So our most frequent error types were mistranslations, coherence errors, and style and register errors. We might expect that mistranslations and coherence errors, for example, have a worse effect on reading behavior, or a greater negative effect on reading behavior than, for example, style and register errors, because each error that really impacts the comprehensibility of the text, we expect these type of errors to have a greater effect on regressions, for example, and the time that a word is fixated. And this is exactly essentially how we can assess the seriousness of all these different error categories, by studying the end user, the reader of the text itself.
Thank you. Thank you. Very interesting. Okay, other questions in the room? No.
I finished a bit earlier than expected, I guess.
Yes, you were very fast. You had so many slides, but you were very fast. So we have, I don't know, 4 minutes before our next presentation. So I suggest we just take a very short break, get a glass of water, or get a coffee, and we'll start again in 3.5 minutes.
Thanks for your attention.
Thank you, Toon.